Okay, in this video, this will be more of an advanced LINEST tutorial in Excel. So, in this video, we will be using LINEST for nonlinear regression, logarithmic curves, exponential curves, and power function. I'm going to assume that you watched the first video where I went over a basic linear LINEST problem. So here, our first problem, we have a nonlinear regression. And so in this problem, we have a polynomial. We have y is equal to ax squared plus bx plus c. I generated this set of number simply through my calculator. I already came up with an equation in this form. And that equation was y is equal to 5x squared plus 3x minus 2. With that, if I plug in 1, I would get 6. And if I plug in 10, I would get 528. So I know this is a perfect polynomial fit of this form. Y is equal to ax squared plus bx plus c. But instead of graphing, in order to know our a, our b, and our c value, we can use LINEST. And so I'm going to show you what you need to type in. Because unlike a simple linear function, polynomial fit, you need to do a little trick. So our 5 corresponds to this. Now this might be hard to see, so I reproduced it here. So you would say is equal to LINEST parentheses our y value, C5 and C14 are y value, comma, B5 and B14 are x value. Now this is a trick. You say a caret, curly bracket, 1 comma 2. You do 1 comma 2 if you have a second order, meaning like x squared. If this was a third power, you would say 1 comma 2 comma 3. Then you do your standard comma true comma true. Next, we'll do logarithmic curve. Likewise, I simply generate this curve, this data set, by already knowing our points. So I already used my calculator to generate this set of data points. And so for logarithmic, there's another trick. So this might be too hard to see, so I reproduced it here. So the standard y, the x's, now you say comma, ln, the x value. And you're doing this because this right here where your x is attached has an ln. That's why you need to put ln in the front. Comma true, comma true. And if you do this, it will match. Your m value is 7, which is correct, and our b value is 3, which is correct. Our r squared right here is 1. Next, we will do exponential curve. Now this is where kind of you need to know a little bit of math. So if I take the natural log of y, I take the natural log of this side here, we would get ln y is equal to ln a plus bx. Or you could say ln y is equal to bx plus ln a. And let's see what equation we used. So we say is equal to LINEST parentheses ln of c, this the y term, comma our x term. And let's see how you would get a. So now in order to get a, because once you solve it, because once you do this, you're actually solving for ln a. But you want to solve for a. So this is what you need to do in order to get a. You simply raise it to e. Because if I put an e right here, this e and the ln would cancel, and so we would get a. So this is correct. And lastly, power function. So the standard power function would be y is equal to ax raised to b. You need to do a little bit of math in order to make it into a better form. So you could say ln y is equal to ln a plus b times ln x, or you could do log y is equal to log a plus b log x. I actually did log. So, and this term right here would be is equal to LINEST log, so our y term, comma, log of the x term, comma true, comma true. This would give us the b value. The b term right here would be 2. And when you solve, and then this term right here would be log a, and you want to solve for a, so you simply need to raise it to 10. So you say 10 raised to this term, and this is how you would get the 3. And that's all you need to do in order to solve for power functions, exponential curves, logarithmic curves, and a polynomial using LINEST.